Hi, welcome back. My name is Grady King. Today I'm going to be talking about the LabVIEW FRC robot project, which is essentially how all FRC LabVIEW code is written for the robots that we code for. There's not going to be a challenge at the end of the video because it's just a general overview. You're not going to be writing too much code or anything like that. You're going to be moving motors and reading sensors and stuff very soon, but there's a few things that I need to get through after this before you're able to do that. So let's just get into it. Alright, so the way to create a FRC robot project, there's a nice convenient button here that creates a new one here, or if you go to File, New, you can go to the FRC RoboVIEW robot project. If you're wondering what the RoboVIEW is, it's the computer that controls the robot. It houses the code and controls everything. So that's what this project is for. So if you just click on that and hit OK, you open this window for creating a new robot project. You can give it a name. Let's call it, I don't know, LabVIEW example. And you can put it into a folder of your choice. So I'm going to go into here and put in your team name, 2614. That's important for connecting to the robot and a few other things. And we're just going to stick with arcade drive. Essentially, arcade drive is a way to control a robot using like one or two joysticks. Essentially, like you can go forward, back, and you can spin, so it's kind of like driving a car-ish. Command and control is a separate thing. We don't really need to get into it, and these are just some examples. Normally we just go for arcade drive and just modify the program to our needs. So let's go ahead and hit finish, and it'll create our project very quickly. So you'll see a few things here. This target is essentially everything inside this drop down is code that's going to go onto the RoboVIEW. And the main code that kind of houses all of that is something called robot main. Robot main runs first and everything is contained in it. So let's go ahead and open it up and I'll explain how it works. So you'll see the front panel shows up. If you hit Control E, you open the block diagram and you'll see this. It might look a little complex right now, but you'll get very used to it very soon. The first VI that runs is something called begin. And basically what it does is we need to tell the robot what's in it, what we're like, all the devices, all the motors, all the pneumatics, all the sensors and stuff, so that we can reference them later in the code. So that's what begin does. Begin runs once at the very beginning, and then everything else runs after. So if we go ahead and open it up, there's a bunch of default things here that we don't necessarily need, that you could use, but we don't normally use them. But one thing we do use is initializing a joystick. A joystick is basically any type of controller or anything. And this is kind of a good example of how everything is initialized in FRC. Essentially, there's one VI here called joystick open, WPI joystick open. WPI, by the way, is the institution that basically creates all of the low-level code for FRC. So they're a very important thing for FRC. But anyways, joystick open will essentially it takes in a ID. So there's 6 different slots that you can use for joysticks. Normally we use 2 at max, but the default is USB 0, so it just starts with USB 0. What gets passed out of this joystick open is a cluster, which contains a bunch of different information. In terms of the joystick, I think it only contains one, which is the device ID, but for motors and stuff, there's a whole bunch of different information in there, but you don't really need to worry about that. this cluster gets passed into the next VI, which is something called the refnum registry set. And that's kind of a fancy way of saying we're just going to name it. So the refnum name gets passed in, and that's just a string, and that's just the name of the joystick. So normally we call it pilot. That's the main controller, and then the co-pilot is the secondary controller. And pilot normally controls major movements and stuff, but I'm getting ahead of myself there. So essentially this string gets passed into this registry set, and that's what that VI does. And what we can do with that is later on in the code we can use something called registry get, and we pass in the same refnum, and you're able to get all that data and make any modifications. You can get data, set configurations, etc. But essentially that's what refnums do. A few other things. This is the default way of initializing the motors for the arcade drive. We don't necessarily need to worry about any of this or anything up here right now, but that's essentially what begin does. It initializes the motors or the joysticks or anything like that, and allows us to reference them later, and this runs once. So let's go ahead and close that. The next most important thing is something called teleop. And let me open the driver station here so I can display what I mean here. So here's the driver station. It might be in a window for you like this. If you hit this window, then it sort of neatly goes into the bottom here. And I actually need to move my webcam. Let me move that up. So there's 3 main different modes for an FRC robot. And each of them have an enabled or a disabled state. So teleop is it's sort of the main mode for a robot. Essentially, it's controlled by humans with a controller. And so the idea is that when you put in inputs into a controller, and then you get movement out of the robot. And whenever a robot's disabled like this, that means that it can't move. There's no way for a motor to move or a pneumatic to move or anything like that, and that means that it's safe to be around. Whenever you hit enable, that means that it's enabling any movement, and so whenever you enable a robot, and I am very insistent about this, and I hope Pratham will be, and any future programming leads, whenever you hit enable, yell enabling, so everyone around you knows that there's a potentially unsafe scenario, and to watch out for any moving robots. But anyways, so teleop is the main mode where the controller controls the robot. Autonomous is essentially where the robot controls itself with no human intervention. This really happens in the first 15 seconds of any FRC match, is the autonomous period, yeah, that's basically self-explanatory. Same enable disable thing with that. The test mode is something that's a little bit more ambiguous. It's normally used to test out the robot, test different components. So most often this will have, like, in terms of like a bigger robot, it'll have a bunch of manual small adjustments that you can make just to test out each motor and maybe get it into a certain configuration, etc. And those are the 3 main modes. There is practice mode, which is sort of a combination of teleop and autonomous. It's more to simulate an FRC match, like in terms of the timings, like so you don't really need to worry about that right now, but worry about teleop and autonomous and test. So whenever we go into here, this case structure is actually what runs teleop, autonomous, and test. So here's the teleop VI here. This is where you put in all of your teleop stuff. So let me explain a little bit of what's going on here. So you see this is our registry get that I talked about before, and you need to make sure that the name is the same between the two ref nums so that you get the right information. And you'll see that you get the same cluster that you got before, and you can just pass this into something called get values, which passes out basically all the data that you'd want for a controller. You see that there's 3 different outputs here other than the error, which is axes, buttons, and POVs. Axes, here, if I go into the driver station, you can kind of see this. I need to plug this in. I guess I'm going to unplug my mouse for now because I'm running out of USB space. But if you look in the controller here, so you see if I have a USB plugged in here, you can see if I move around the controllers, you'll see those little green lights moving all around. So the axes are essentially the parts of the controller where you can you basically have like a range of values. So for example, for left x-axis, that's the left joystick, left and right, and that ranges from -1 to 1, and normally stops at 0. Same for y-axis. The triggers are on the top, and those range from 0 to 1. They don't go negative because whenever it gets all the way to the top, that's 0, etc. The buttons are just all of these buttons on the controller, including like pushing in the stick, the bumpers on top, even these like menu buttons and stuff. And this is numbered from 0 starting up here down to, what is that, 0, 1, 2, 3, 4, 5, 6, 7. And then it starts back up here at 8 and goes down again. And you notice that these are arrays, which I talked about before. So what's happening here is this is a 1D array of numerics, and it's going into the index array block, which I talked about before. And this defaults to 0 at the top. So what it's taking is taking the 0th and first element of this array, which if you look at axes, that's the left x-axis and the left y-axis. And that's getting pushed into the arcade drive, which is, remember, that's what the default project does, is it makes it an arcade drive. So yeah, that's how that works. And it's the same thing with the buttons. You could take index array and say grab this, and you could grab the A button, which would be the 0th index, grab the X button, which is the 2nd index, etc. And you can grab all of the different buttons that are on the controller. And so that's kind of what you do in teleop. You take those joystick commands and you send them to the motors and stuff. That's the general idea. If we go to different cases here, if we go to autonomous enabled, there's this kind of special thing here called a start-stop VI, and what it does is it takes, this is kind of complex, but it takes a reference to the autonomous independent VI and then runs it in here. Essentially that allows it to sort of run in, it allows things to run in parallel a little bit better. It's kind of it's an optimization thing, but essentially autonomous code is run. The autonomous independent has some examples of what you could do in autonomous. I'm going to talk about autonomous later, but there's a few examples of how you could potentially do autonomous. An important thing to know about autonomous is something called the auto selector, because there are different plays that you want to do depending on where you are on the field, etc. So it's important to keep in mind that you have to select which play you're going to be doing, and that comes from the dashboard, which I'll be talking about later also. But that's kind of the most important thing to know about autonomous. And yeah. Test is sort of the same thing. It's also run in the test enabled, where there's the start stop VI, and it's run by a reference. And it's sort of the same thing. It looks a little bit different than teleop by default, but essentially it's sort of similar to teleop, but it's going to be more manual movements. But test is more important when you have a huge robot with a bunch of different components, so you're not necessarily going to be worrying about test for a while. The next thing I'm going to be talking about is time tasks, which is also called periodic tasks. I don't know why it has two different names, but essentially it's ways that it's a periodic loop that runs every X milliseconds. For example, by default, there's a 10 millisecond while loop and there's a 100 millisecond while loop. This is in the actual Mars architecture. This is actually where a majority of our code runs. But for the default project, this might be where you read a sensor every 10, 20 milliseconds and just see what the value is, and you might write it to a certain variable and read it in teleop or something like that, because you probably want to be reading a sensor regardless of whether you're in teleop or autonomous. One important thing to know about periodic tasks is that it runs all the time. It runs whether you're in enabled or disabled state, whether you're in teleop, autonomous, test, whatever. It's always running. So it's a good thing to have for things that are continuously running all the time. There's a few other things that are sort of low-level things. There's this NT server, which starts up this thing called network tables, which is most important for communicating between the RoboRio and the dashboard, which like the dashboard's coming up over and over again, which is remember that's how the drivers are able to see data on the robot and communicate with it, and that basically starts that server, that network tables server, which allows for communication. Another thing that it allows is something called the limelight. The limelight's a sort of camera that we use that spews out green light that will definitely blind you if you look at it directly. But basically the data from the limelight goes through network tables through to the RoboRio. So that's another thing that network tables are useful for. There's another thing called robot communication, and that basically just allows communication between the RoboRio and the driver station. And there's another thing here for sending images to the PC, which is basically taking any sort of USB camera and putting it to the dashboard and handling that sort of thing. We don't normally use USB cameras that much. We normally just use the limelight, but I've seen a few there's a lot of robots that use USB cameras, like the one I have right now, that you can just plop on the robot and you're able to see from the robot's perspective, which can be really useful in lining stuff up. So that could be potentially used. One important thing to notice is that this is actually a loop. You notice it's called the scheduling loop, and it basically just makes things run all the time. This get mode will basically takes this reference from, it's kind of like, there's this thing called an occurrence, which is kind of ambiguous, but it's sort of referencing the robot itself, and it's basically this driver station taking in this occurrence and getting the mode from the driver station. So whether we're in autonomous enabled, autonomous disabled, autonomous enabled, autonomous disabled, test enabled, test disabled, etc., and that passes into this case structure. And there's also this robot mode global variable, which I don't remember if I taught you about global variables or not, but I will in the future, which is something that you're able to reference anywhere in the code. So if you want to know what mode you're in, you can just compare with this enum, and you're able to see all the different types of modes. And there's a few other things. There's enable vision and image size. We don't normally use that too much, but it's important to see. And you'll notice that there's a finish button on the front of robot main. This is something that's sort of archaic and something that we don't normally use, but if you do hit the finish button while the code is running, it will stop the robot. And the idea is that it runs this finish VI, which is supposed to be something where you like close every motor, but with how code is structured now, it's not really that useful. But you notice that will actually end the while loop and end the code, but not necessarily too important. But that's sort of an overview of all of this code, all of this structure, and maybe start getting you thinking about how you would structure code, which you'll be writing very soon. But yeah, that's all I have for today, and hope you have a good day. Ask me any questions or any other programmers, etc. And yeah.